Advanced Algebra 2, solving linear systems algebraically. This method is a lot more reliable than solving by graphing. There's two different methods that you can use, substitution or elimination. These will probably be review for you. First, we're going to start with the substitution method. So the steps are that first you're going to solve one of the equations for one of its variables. Look for variables that have a coefficient of 1. And you can solve for either x or y. The second step is that you're going to substitute the expression from that solved equation in step 1 into the other equation, and then solve for the other variable. And then finally, one more substitution step. You're going to substitute the value of the first variable that you got from step 2 into your revised equation from step 1 and solve. So we'll put this to action and these steps will just become clear. So right now we're just solving by substitution. So look at that example number 1. So we have the system 2x plus 5y equals 7 and x plus 4y equals 2. So you can see in the second equation that you have your x variable with the coefficient of 1. So let's solve for that variable. So we'll subtract 4y, and you can put it behind the 2. And then you're going to take the value of x, which is 2 minus 4y, and you're going to substitute all of that into your first equation for x. So when you do that, the x comes out and the entire expression goes in. So you'll want to group it in a parentheses. Then you'll just complete the equation and then solve for y. So the first thing you'll do is distribute. Then you're going to get your like terms together. So I'm going to subtract my 4. And then negative 8y plus 5 is negative 3y. 7 minus 4 is positive 3. Since we're multiplying by negative 3, divide both sides. So you have found out that first equation. So here we had step 1 and then step 2 when we plugged it in and solved. Now the next thing we're going to do is step 3. So that's where we're going to take the value of y. We're going to plug it into our revised equation. That's the one where we have solved for that single variable, because that will be the easiest. So we'll take 2, negative times a negative is a positive, plus 4, so x equals 6. So without graphing, we found the place or the point where these two lines intersect. Now you can always check, so you can just plug the value for x and y back in. I'm going to do a lot of this in my head. So in the first equation, 2 times 6 is 12. 5 times negative 1 is negative 5. And I'm checking to see if that equals 7, and it does. On the second equation, I have 6. 4 times a negative 1 is negative 4. And I'm checking to see if that equals 2, and it does. So you can easily check your solution. And then this, since it's crossing at one point, well, since it's crossing, first of all, since it does share at least one point, this system is consistent. And then since it's a single point, it is independent. Now look at our next one. Oh, sorry. So the first equation has y with a coefficient of 1. Jack. Add your 2x to both sides. And take that value and substitute it into the second equation. So we got 6x anytime minus 3 times 2x minus 5 equals 15. Do you see when we substitute them in, then we have just a single variable equation. Now, as you're solving, you might notice something interesting happening. So we've got our x's eliminate. They subtract out. And we are left with 15 equals 15. So that's an algebraic clue when we end up with a true statement. That's always true, that one number equals itself, that we can plug anything in for x, and those two numbers will always equal each other. So if we were to graph these two equations, they would graph as the same line. So this is algebraically how we know when we have a system with infinitely many solutions. You end up where one number equals a number, and it's a true statement. They do indeed equal. Now the second algebraic method is elimination. So when we do that, we're going to try to get either our x's or our y's in a situation so that if we add or subtract them, that they will eliminate. So the step goes, number one, that you're going to multiply one or both of the equations by a constant to obtain coefficients that differ only in sign from one of the variables, or they can also have the same sign. Then, depending on if their sign is the same or opposite, you're going to add or subtract those two equations. We don't have to add. Combining like terms and solving for that variable. Then the third step is going to feel like the third step in the substitution, where you take the value that you solve for either x or y and plug it back into that other equation, that first equation. So let's look at one of these systems. So we have 10x minus 2y equals 16. 5x plus 3y equals, oh man. So look vertically. Here, 10x and 5x, so we can multiply that second equation by 2 or negative 2, and we could get a 10x or a negative 10x. With the y's, we need to multiply both of those to get a number that was either equal or opposite. So I'm going to go with the easiest. I'm just going to multiply my bottom equation by 2. So the first thing I'm going to do is just rewrite my top equation. Then, as long as you do everything to the terms in an equation, you don't change its value. It will still all be equal. Now, my signs are the same with my 10x's, so I'm just going to subtract everything. 10x minus 10x is 0. And that's good. I want one of my variables to eliminate. Negative 2y minus 6y is negative 8. Y's 16 minus a negative 24 is like adding 24. So that will give me a positive 40. I'll divide both sides by negative 8. So y equals negative 5. So we just completed steps 1 and 2. Now we're going to take our negative 5 and plug it into one of the originals. It doesn't matter which one, it's just whichever one looks easiest to you. So to me the top equation looks very doable. So I have 10x minus 2 times negative 5 equals 16. 10x plus 10 equals 16. 10x equals, if I subtract my 10 I get 6. So x equals 6/10 or 3/5. So these lines are crossing at the point 3/5, negative 5. Now check that, okay? Plug in 3/5. Don't use your calculator. You can just set it next to 3/5 times 10, 3/5 times 5. It's very easy just to multiply those. And you'll see that it checks. So sometimes you will get an answer that has a fraction. Do not put it in to a decimal unless the decimal ends. If it doesn't, just keep it in fraction form because that is what we call exact value. Now look at number 4. So notice we've got our x's 3 and 6, our y's 4 and 8. So we want to eliminate one of those. I'm going to get opposites this time. So I'm going to multiply my top equation by negative 2. So I need to multiply everything by negative 2. I can already see that something strange is going on, because in my x's and y's, now I have both of them as opposites. But my numbers did not work out that way. So since I have opposite sign of the x's that I decided to eliminate, I'm going to add. So negative 6x plus 6x is 0. Negative 8y plus 8y is 0. Negative 36 plus 18 is negative 18. So this is the algebraic clue that you have a no solution situation, because this is an untrue statement. 0 does not equal negative 18. There's no number that we can plug in that's going to make those two equal. So this is no solution. If we were to graph these lines, we would have two parallel lines. Well, our last problem is not three variable systems. It is not that. There. It's a real life problem. So I've given you a little graphic just to help give you a process on how to set these up. So to raise money for new football uniforms, your school sells t-shirts. Short sleeve t-shirts cost the school $5 each and are sold for $8. Long sleeve t-shirts cost the school $7 each and are sold for $12. The school spends a total of $2,500 on the t-shirts and sells all of them for $4,200. How many of the short sleeve t-shirts are sold? When you've got a situation like this with two things involved, we're going to have two variables. So what are our two unknowns? Now it's only asking for short sleeve t-shirts, but we also don't know how many long sleeve t-shirts there are. In problems like this that have a real life context, I like to use a variable that will help me remember what it stands for. So I'm going to use T for short sleeve t-shirts. And then I'm going to use L for long sleeve. And when I'm talking about the number of those. Now there are two things that we were told about. And so we were told about how much they cost and then how much we sold them, or the school sold them for. So with the short sleeve, it cost $5. For the long sleeve, so we're going to have to jump down here, it cost the school $7. So $7 per each, or times each long sleeve. And then together with those, the school spent $2,500. So we have to jump around a little bit to create our equation. Now with our sold equation, so the short sleeve are sold for $8. The long, so I'm going to box that in. The long sleeve are sold for $12. So we'll add that. And then we are told that once all of them are sold, it's $4,200. So now we have our two, and these are equations. So it's not a range, it's just equaling those amounts. So then after you write your equations, you just check back and say, does it say what I want? Sure, these do. The cost of short and long sleeve together is $2,500. The cost, or not the cost, but what they're sold for, brought in $4,200. So with this, I am not going to graph. I usually do not. And I do not have a coefficient of 1, so I'm going to eliminate. So I look at those, and I'm just going to work with my t's. I'm going to multiply my top one by 8 and my bottom one by 5, so that I have a common value of 40. So 8 and 5. I'm not going to multiply by a negative. I'm just going to get these both the same, and then I'm going to subtract. So 20,000, and then 40t plus 60l equals, and I think that's 21, but let me check that. Yes, 21,000. All right, now I'm going to put a big subtraction out to the side. So I'm going to subtract 56L minus 60 will give me negative 4. That's okay though, because my number over here is going to be negative. So I divide both sides by negative 4, and I get 250 long sleeve. Well, if I would have eliminated the other way, then right now I wouldn't have my answer. But that's okay. So I'm going to just take my 250 and I'm going to plug it into one of my original. So I think I'm going to take this and I'm going to plug it into my top equation here. So what that's going to look like is 5t plus 7 times 250 equals 2,500. So we'll just take 250 times 7, which gives us 1,750, and then subtract that from 2,500. So 5t equals 750. And then one more step, just divide by 5. So 150 short sleeve. And then you can plug those back in and make sure that they make each of our conditions work, that together, if we sold that many, we brought in $4,200 and then with the cost that it was $2,500. So that's a good way to think of a word problem. So first of all, think about, here we go, your variables. What are your two unknowns? And in this case, it was only asking for one of us, but there are clearly two things they were talking about. Your equations, meaning what are the two number situations that we were told about, like the cost and then the sold amounts. And then always check once you set up your equations, do they say what I want? And then choose a method to solve.